Welcome back to the third installment of the Firestore Enterprise Queries mini-series. In case you haven't watched the first two videos, you really need to if you want to fully understand this video. But in case it's been a while, here's a quick refresher. Firestore Enterprise Edition can perform queries like in Firestore Standard Edition, except in addition to scanning indexes, which is fast, they can also scan collections of documents directly, which is slow. Remember, indexes are fast because they're ordered or otherwise have special properties that make traversing them to find a specific value scale efficiently with the size of the index, and thus the size of the collection. Generally, Firestore Enterprise Edition will use indexes you create whenever possible, including in cases like count aggregations, just like Standard Edition. Firestore will also use indexes to support queries even if the index doesn't fully cover all the sorts and filters on the query, which can grant significant speedups depending on the scope of the sorts and filters. So with that in mind, the key to writing performant pipelines is to use an indexed field to scope the query down at the beginning of your pipeline. Then do all your expensive scanning on a subset of documents that's guaranteed to be small. And as a corollary, for any order or filter that you want to run against an entire unbounded collection, you should make sure the fields you're ordering and filtering on are indexed. Let's go through some examples. Here's a core operations compatible query expressed via the Pipelines API. Just like with Standard Edition, if you build a single field index on the rating field, this query will return results quickly because traversing the index to find all documents with a rating greater than 4 is fast. Pipeline operations are a superset of core operations. So if you use Enterprise Edition and index as well, you can improve performance while also writing more powerful queries. If you don't create an index, you'll need to scan the collection for every document that might have a rating over 4, which is guaranteed to scan the entire collection on every execution of the query. Here's another example, except we're filtering on two separate fields. If I run this query with no indexes, it'll again complete in linear time as Firestore scans the collection to find all the valid documents matching my filters. But if I build an index on just the author field, Firestore is able to use the index to quickly scope the query down to just documents matching the first equality filter, recipes whose author is named Morgan. And then the documents it scans are only the documents in that potentially narrow range of the index. So if Morgan has written only a few hundred recipes, this query will execute quickly even though the rating field is still unindexed. With both fields indexed, you get the same fast performance characteristics as the previous query, where the performance scales with the size of the return document set, which is capped to a constant in this example. This query here is more or less identical to the previous example, except we're sorting on a field value after applying a transformation to it, which means even if we index the field, the transformed value won't be represented in that index. The indexed and unindexed performance of this query are both linear as you'd expect. But we can make it fast by storing the value we're sorting on in the document itself, and enforcing consistency by writing through a cloud function. Then we get the same fast performance of the first example. In this example here, both an indexed and unindexed recipes collection will have linear time performance, but the indexed collection will be much faster since Firestore can count the index entries instead of having to count documents, and index reads are faster than document reads. The field that's indexed here doesn't matter. For other aggregates like countif, sum, and average, the speedup is dependent on whether or not Firestore can fetch all of the data it needs from the aggregate from the index. If not, it must scan the documents, which is slower and costlier. How about this one? There's no index speedup for regex comparisons, so this one will exhibit linear time performance for both indexed and unindexed collections. In the future, an index might grant some scalar performance benefit here since we could pull field data out of the index instead of having to load the document. Hopefully these examples will help you build some intuition around how a particular pipeline query will perform. Once you've written your queries, how do you know if they're running slowly or not? In the Google Cloud Console, we have a query explainer that shows you which queries you've been running and how long they've been taking to execute, as well as whether or not they've been making use of index reads. You can use this page to see which queries are causing latency issues in your actual live application, then hop over to Firebase Console's query explainer to examine the actual execution steps of the query you're running to figure out what's causing the slowdown. Take a look at the documentation for Query Explain for more details. Some of you who like math may note that I've been specific about unindexed worst case performance, but a little vague on best case performance. If you remember your algorithms and data structures, traversing an ordered list to find a value can be done in logarithmic time via binary search. So shouldn't Firestore's indexed lookups also have the same performance characteristics if they're using ordered indexes? And the answer is maybe. As I hinted at earlier when I was talking about index scanning, Firestore has multiple strategies for resolving queries, and likely will add and modify strategies going into the future. Firestore may even modify the implementation of indexes so it's not guaranteed they're always using binary search. So it's difficult to give an exact time complexity once indexes are involved, but the completely unindexed case is always linear because that's how long it takes to read every document in a collection. However, Firestore does guarantee that for straightforward indexed queries, everything I said was fast in the examples just now, the runtime scales with the size of the returned result set, meaning you should see similar performance when running those queries regardless of the size of the collection you're querying. Finally, let's revisit this query from the second video in this series. The select at the top can actually be omitted without changing this query, since Firestore knows this query will only ever need to read the tags field. Firestore will implicitly insert the select for you. While this may be confusing, you can think of Firestore's query optimization strategies like compiler optimizations in your code, which is to say you don't have to think about them at all, and hopefully we'll add more of these optimizations over time, and you'll just notice Firestore is slightly faster than it was a few years ago. Firestore Enterprise Edition brings with it a whole host of new querying capabilities, as well as a whole host of technical complexity. We bring you these new features at the cost of their complexity because we believe if you take the time to understand Firestore Enterprise Edition, you'll be able to write richer, faster apps that use less database resources. I hope this video has given you a sense of how Firestore works behind the scenes, and with it, the knowledge to write performant queries to enable even more flexible feature development for your apps. And if you don't like hearing about constant or linear time performance, or are otherwise just confused by indexes, you can always simply use Standard Edition. As always, we'll continue to add new features and make other improvements to Firestore after the release of this video. We might add new pipeline expressions and stages, or new query resolution strategies. We could even add new index types. We'll add more videos to this series to cover any major changes if they ever let me back in the studio. In the meantime, please check out our docs for the latest information, as well as a complete reference of all of the features I discussed earlier. That's all for today. See you next time.